Hi everyone, welcome back to Made Everything Official. For more than a century, Survey Group has been a leading name in power and motion control, designing and manufacturing hydraulic systems trusted across the world. With headquarters in Norway and service partners on 4 continents, the company delivers precision-engineered solutions for the most demanding applications. At its Rissa facility, just north of Trondheim, Survey develops and manufactures advanced hydraulic cylinders, valve blocks, accumulators, and HPU systems for heavy industry and offshore use. Using state-of-the-art design tools and simulation software, engineers virtually test each mechatronic system before it ever reaches production, ensuring that every solution performs flawlessly in real conditions. The facility uses renewable heat pump energy, drawing pure thermal power from the nearby sea to reduce carbon dioxide emissions and energy costs, proof that sustainability and heavy engineering can coexist. Inside the workshop, CNC multitasking machines like the Mazak Integrex handle complex, turning and milling in a single setup. For large diameter cylinders, submerged arc welding and specially designed joints provide exceptional strength and reliability. Every weld is certified, inspected, and documented to meet strict offshore and class society standards. Survey Rissa produces hydraulic cylinders with piston diameters up to 2 meters and strokes reaching 20 meters, all tested under pressure and verified for cleanliness and functionality. With innovation, precision, and a deep engineering heritage, Survey continues to shape the future of power and motion control, made in Norway, built for the world. Welcome to Buddy Bar Casting, a world-class manufacturer of high-quality, complex aluminum castings that serve aerospace, industrial, marine, and construction applications. From initial tool design through casting, machining, and finishing, all steps are executed in-house, delivering performance, repeatability, and American quality. The journey begins with tooling and mold design, sand casting, core making, and pattern preparation under strict quality control. Buddy Bar handles jobs from small precision pieces to large industrial castings, offering everything from melt shop operations to finished components. Their foundry lines produce molds by the thousands per shift, each capable of forming intricate geometries with tight tolerances. Once the castings are stripped, they move to a dedicated machining area. Horizontal and vertical machining centers, automated pallet systems, and in-house fixture construction allow rapid turnaround and high accuracy. Deburring, shot blasting, robotic cleaning, and finishing ensure each part meets surface and dimensional specifications. Buddy Bar's quality assurance programs follow rigorous standards, including MIL-STD, Tier 2 supplier certifications, pressure leak testing, and full traceability for each component. Material capability covers primary and secondary aluminum alloys customized per project. On the sustainability front, the foundry leverages a thermal sand reclamation system, reclaiming used mold sand and reducing landfill waste, a clear example of industrial responsibility. From concept to delivery, every step is controlled, documented, and optimized, providing engineering-grade components that power tools, ships, vehicles, and industrial machines around the world. Buddy Bar Casting doesn't just make parts. It delivers engineered solutions, precision-made, and quality assured. In the world of heavy metal forming, innovation often means applying heat, force, and precision in perfect harmony. Repkon's hot spinning machines represent just that. Advanced technology applied to forming high-performance cylindrical and conical components for aerospace, defense, energy, and heavy industry. Today we'll take you through how this machine turns a red-hot blank into a finished, high-precision part with minimal waste and maximum control. Hot spinning begins by heating a cylindrical blank, often steel or alloy, to a forging-level temperature. Then, while the part rotates at high speed, rollers or spinning heads press against the surface, gradually forming it over a mandrel. On the Repkon machine, the workpiece is mounted and heated uniformly. The rollers apply the controlled deformation needed to form shapes that would be difficult or impossible by conventional methods. This method allows for large diameters, complex geometry, and excellent material properties, all without extensive machining or material waste. Whether the end result is a rocket motor case, turbine housing, or heavy pressure vessel sleeve, the hot spinning process delivers efficiency and repeatability. What sets Repkon's machine apart is the integration of automation, monitoring, and tooling precision. Sensors track temperature, material behavior, roller force, and deformation in real time. The control system adjusts parameters to maintain tolerance and avoid defects. Hot spinning is especially beneficial when materials are difficult to form cold, like high-strength alloys used in aerospace or defense. Repkon lists this technology under its hot spinning and flow-forming capabilities. In the factory, the machine forms shells, cones, hemispheres, and complex hollow parts with minimal seams and excellent microstructure, reducing welding, machining, and finishing costs downstream. From raw heated steel to finished precision part, the journey on the Repkon hot spinning machine is a study in modern industrial mastery. Whether you're building turbine casings, missile bodies, or large-scale pressure vessels, this machine demonstrates how heat, rotation, and force combine with digital control to produce extraordinary results. This is the story of a highly complex turned part with precision threading, a component born from advanced CNC turning technology and expert machining. Rotational symmetry, intricate geometry, and a precise thread combine to create a part that demands the highest levels of craftsmanship and automation. The process starts with a chosen stock, often stainless steel, alloyed material or engineered metal, selected for strength, machinability, and application demands. On a multi-axis CNC lathe, the blank is mounted, centered, and aligned. Toolpath programming, spindle speed, feed, and thread parameters are all defined. Thread cutting, whether internal or external, is integrated into the sequence for seamless production. Complex contours, grooves, bores, and the external or internal thread are often produced in one setup, minimizing repositioning, reducing error accumulation, and improving repeatability. As the cycle begins, the lathe engages. Turning operations create the outer and inner profiles, often handling multiple diameters and stepped sections in a single run. Then the thread cutting stage engages, either via dedicated threading inserts, thread rolling, or thread whirling, depending on the material and specification. The result is a perfect helix with accurate pitch, depth, and surface finish. Simultaneously, other features, such as keyways, grooves, crossbores, or flanges, are machined, integrating the geometry into a complete, functional component. The entire process is supported by real-time monitoring, spindle load, tool wear, vibration and dimension feedback ensure the final part meets tolerance and specification. In modern manufacturing, parts like this prove that turning is far more than simply rotating metal. It's the fusion of automation, precision engineering, and material expertise. When you see a component with complex geometry and a precisely formed thread, you're looking at the result of integrated CNC turning, advanced tooling, and exacting standards. In the realm of large-scale metal forming, automation and volume production go hand in hand. Oscock hydraulic transfer press systems deliver just that, for factory floors that produce thousands of identical parts per day. Here, we watch the press in action, forming steel kettle bodies with precision, speed, and repeatability. The blank sheet is loaded automatically, then guided into the transfer station. With each cycle, the press moves the part through multiple stations, forming, trimming, shaping. The integrated automation ensures minimal manual handling and high uptime. The transfer press is engineered for continuous output, feeding, pressing, transferring, all within one synchronized cell, reducing waste, cutting cycle time, and maintaining consistent part geometry. Whether for kitchen appliance shells or heavy industrial containers, the kettle production line here demonstrates how mass manufacturing meets precision engineering. From sheet metal to finished kettle body in one smooth flow, that's the power of high-end hydraulic transfer press technology. In a world where sustainable energy is more important than ever, hydropower continues to stand as one of the cleanest and most reliable renewable sources. This is the production of a Pelton runner, the beating heart of small hydropower plants designed for efficiency, precision, and long-term durability. The process begins in Austria, where engineers design each turbine using 3D CAD and CAM systems. Every blade profile, curvature, and flow angle is optimized to extract maximum energy from high-pressure water jets. The Pelton runner is machined from a single solid stainless steel monoblock on a 5-axis CNC machining center, a process requiring hundreds of hours of continuous precision milling. During rough and finish machining, multiple tools operate automatically, shaping each bucket with perfect geometry. Tolerances are verified in real time, ensuring the finished runner meets strict hydraulic and mechanical performance standards. After machining, the runner is polished, balanced, and tested for flawless rotation and efficiency. In the United Kingdom, advanced electronics manufacturing plays a key role in industries that power modern life, from automotive and medical devices to broadcasting and energy systems. This facility specializes in full turnkey PCB assembly, providing complete manufacturing, testing, and logistics services under one roof. Each circuit board is produced through automated surface mount and through-hole processes, featuring solder paste printing, component placement, and precision reflow soldering. 4 dedicated SMT lines handle components from micro BGA packages to high-power modules, supported by laser and optical inspection systems for quality control. Manual assembly, ultrasonic welding, cable harness production, and conformal coating ensure that even complex projects are built to exact customer standards. Every product is tested in environmental chambers, simulating extreme heat, cold, and humidity. Stringent high-voltage and functional testing guarantee performance up to 6.5 GHz signal integrity. In the world of industrial manufacturing, even the smallest parts can require the most advanced machines. Today, we explore an automatic bolt-making machine, a production line capable of turning wire rod into finished bolts, fast, reliably, and at scale. From cold heading to thread rolling, this machine embodies automation, precision, and heavy-duty performance. It begins with a straightened wire rod fed into the machine. The first station cuts the rod to the required length. Then a cold heading press forms the head of the bolt. Next, the machine may reduce diameter over a length, punch or trim the blank, and transfer it to a thread rolling station. According to manufacturers, some all-in-one machines cover all steps from cutting to sorting finished bolts. Rolling jaws imprint the thread onto the blank, creating accurate threads without cutting, which improves strength and grain flow. Finally, finished bolts are sorted, packaged, or sent on for heat treatment and coating, depending on specification. Modern bolt-making machines are modular, highly automated, and designed for high throughput. Some machines handle rod diameters up to 44 millimeters, lengths up to 380 millimeters or more. The automation includes servo-driven rod feeding, straightening units, preforming, trimming, threading, even milling or welding for special bolt types. Such flexibility means manufacturers can produce bolts for automotive, heavy construction, industrial equipment, or infrastructure, tailored to specific grade, thread pitch, and material. With less manual handling, fewer setups, and faster cycle times, production scales well, and cost per bolt drops. Repeatability improves and quality stays consistent across large volumes. From a simple piece of steel wire to a precisely formed, threaded bolt ready to fasten structures and machines, the journey demands engineering, automation, and control. In factories around the world, such automated bolt-making equipment delivers components that hold together thousands of machines, buildings, and systems. If you enjoyed this look inside the automation of fastener production, stay tuned for more industrial machine stories here on Made Everything Official and Thank you for watching.